Hello everyone. Welcome to another episode of Deep Dive Knowledge Talk. Hello everyone. To kick things off, could you explain the significance of GPUs in deep learning and how they fundamentally change the way computations are performed compared to traditional CPU processing?
GPUs, or graphics processing units, are like a team of workers in a big factory, each handling a small part of a job at the same time. When we're doing deep learning, we often work with huge amounts of data, like long rows of numbers or vectors. Now, think of a CPU, or central processing unit, as a super-fast, but single worker who can only do one task after another. This worker is really quick at solving one problem, but can only handle a handful of tasks simultaneously. In contrast, the GPU is built to have thousands of these little workers working side by side. Although each individual worker may not be as fast as the CPU, when you have millions of them working together, they can get a lot more done at once. This is called parallel processing. For simple tasks like adding two long lists of numbers, each worker can independently add numbers from the two lists, without waiting for others to finish. This means that while the CPU might struggle to handle the workload, the GPU can breeze through it, making it perfect for deep learning, where we deal with massive vectors. So, in short, GPUs speed up deep learning by using many workers to tackle lots of small tasks at the same time, while CPUs focus on fewer tasks, but try to do them very quickly one after the other.
That's a fantastic analogy. Now, could you elaborate on how CUDA facilitates this parallel processing on GPUs? Specifically, what are kernels, and how do they play a role in executing deep learning operations more efficiently?
CUDA, which stands for Compute Unified Architecture, is like a special set of instructions for our team of GPU workers, helping them work together effectively. Think of it as a playbook that tells each worker exactly what they need to do in order to complete a job quickly and efficiently. Now, within this playbook, we have something called kernels. Imagine kernels as a specific task or recipe that the workers will follow. Each kernel takes care of a smaller piece of the overall job, like adding two numbers or multiplying two lists of numbers. When we run a deep learning operation, we launch these kernels to perform the necessary calculations. For example, when multiplying two large matrices, which are like grids of numbers, the kernel allows many workers to calculate different parts of the multiplication at the same time. Each worker can compute its assigned section independently, and by doing so, the entire operation gets completed much faster than if a single worker tried to do it all alone. In short, kernels are the little jobs that the GPU workers follow, allowing them to perform complex calculations in parallel. This makes deep learning operations, which often involve a lot of mathematical tasks, run much more efficiently on a GPU compared to a CPU.
Great explanation. Now, could you discuss the impact of using CUDA on the training speed of deep learning models? How does the parallel execution of kernels translate into real-world improvements in model training times?
Using CUDA has a significant impact on the training speed of deep learning models, because it allows for the parallel execution of kernels. Imagine training a model like assembling a large puzzle with many pieces. If one person were to do it alone, it would take a long time to finish. But if you have a team of people, each working on different parts of the puzzle at the same time, the whole process becomes much faster. When you write tie-wide to CUDA in a framework like PyTorch, it tells the computer to move the data and the tasks to the GPU. This means that the GPU can start executing many operations simultaneously. For example, deep learning often involves operations like matrix addition and multiplication. With CUDA, multiple threads can handle these operations at once, much like the team members working on different sections of the puzzle. In real-world scenarios, this parallel execution translates into much shorter training times for models. Tasks that might take hours on a CPU can often be completed in minutes on a GPU. This speed-up enables researchers and developers to experiment more rapidly and iterate on their models. leading to faster advancements in the field of artificial intelligence.
That makes it very clear. Lastly, could you touch on how the efficient use of GPU resources through CUDA can influence the overall cost-effectiveness and accessibility of deep learning for researchers and developers?
The efficient use of GPU resources through CUDA can greatly enhance the cost-effectiveness and accessibility of deep learning for researchers and developers. After the breakthrough in 2012 at the Recognition Challenge, where GPUs were shown to effectively train deep neural networks, the popularity of using GPUs increased significantly. This led to the development of powerful frameworks like PyTorch and TensorFlow. Now, with the ability to simply write what to CUDA to utilize GPU power, researchers can accelerate their model training without needing extensive knowledge of the underlying complexities. This means that even smaller research teams or individual developers can access powerful computational capabilities that were once only available to larger institutions with vast resources. By speeding up the training process, GPUs allow researchers to run more experiments in less time, leading to faster discoveries and innovations. This improved efficiency reduces the overall cost of resources because training models on GPUs take significantly less time compared to traditional CPUs. Overall, the combination of powerful GPU capabilities, the ease of use provided by CUDA, and the reduced training times collectively make deep learning more accessible, encouraging more individuals and organizations to engage in research and development in this exciting field.
Thank you all for joining us today. I hope you found this discussion informative and engaging. To recap, we learned that GPUs harness parallel processing to expedite deep learning. They break down complex tasks into smaller ones, allowing concurrent execution on multiple processing units. CUDA stands as a crucial study that enhances GPU utilization. Its kernels guide GPU workers in executing specific operations simultaneously. This parallel execution slashes training times for deep learning models. By leveraging GPUs and CUDA, researchers and developers can access deep learning technology more seamlessly and affordably. Thank you again to our esteemed guests for sharing their insights. Your contributions have enriched our understanding of this fascinating field.